Hello, James. How are you?
I am wonderful. How are you?
Good. Thank you all for joining us. I know we're just getting started, and lots of folks have had lunch, so thanks for coming in, sitting down. I think we have a fireside chat today on learning a little bit about your company, learning a little bit about you. Maybe we can start with that. Just tell us about yourself.
Sure. So I'm the chief architect at Mill5. We are a global systems integrator and technology provider. We work across multiple industries. We do a lot of work in medical device, IoT, AI and ML, financial services. Really, we have a broad focus, but with very focused areas, right? So it sounds like there's not a lot of overlap between medical devices and financial services or IoT, but actually there tends to be. Like when you're dealing with lots of data and you're trying to figure out signal, right, in IoT, that's very similar to the signal that you find in financial services. And we find that layering on AI and ML on top of that helps a lot of our customers. So we've come up with a bunch of techniques, a bunch of patterns and practices that really help our customers bring this to market. And it's transformative, right? We're a global company. We like to work, in the areas where the companies are. So we have a footprint in the United States, some in Latin America. We have technology professionals in India as well as Europe. And we find that being in the same, being able to talk to the people in real time is always so much better than working at a distance. So
Interesting. And I think one of the topics I've been hearing a lot of conversations around this morning, over lunch, is around the idea of deployment.
Yeah. It's interesting. There's a lot of this idea that training your AI models is the hardest part of this. And there's often this misunderstanding that AI is this secret sauce that you add to something and it just makes it better. And there's a lot of effort that goes into training models and all this other stuff, but really the challenge that people have is bringing this to market. Like, how do you take this idea, this nascent idea, create a model, and then actually have it work in production, right? Like, that's really the kind of trick there, right? You can train a model, and it may not necessarily help you in production, right? Like, we've seen customers come to us with great ideas or great concepts that they just couldn't deliver to production for one reason or another. And that's really, I guess, where a company like Mill5 kind of comes in and looks at the whole process from the beginning, from the data scientist perspective, the curation of the data, the training of the data, as well as packaging up and deploying it to production. There's a lot that kind of goes into that.
But when you mention these challenges, and you talk about some of the industries Mill5's in, healthcare, medical, and you say, medical, healthcare, finance. What are those similarities? I mean, these are highly regulated industries as well. Is that part of the challenge? Are there other challenges to mention as well?
I mean, regulation is definitely one of those things that you have to be concerned about. Some of it is where you deploy to. We do a fair amount of AI on the edge, right? So it's one thing if I'm deploying to GCP or AWS or Azure, and I can iterate and I can always go and deploy a brand new model. Some of our models run on devices in operating rooms. They run on devices in oil and gas fields. And you have to make sure that that trained model works as expected in that environment, because you're not getting another opportunity to go out there and fix it, right? So that is really the challenge that I think people miss, and when they introduce AI into there. It's like, how do you make sure that this operates when you can't go kick the box if it's not working?
How can you do that? I mean, if you're in an organization and you have these out in the field, they're in different countries, how do you functionally do that?
You can test in production, right? Like, this is like my worst the worst answer I could possibly give you. It's like, just go out there and test in production. But obviously, when you're talking about the edge, you can't do that. Really, the only way to do that consistently with high quality is to start to automate your process. And this is where we really see you can get a return on your investment in AI. There's a great quote from Google that said that AI and ML is a high-debt credit card that they have to pay all the time. And one of the things that we've noticed is that there's still a lot of by-hand operation in this. And moving some of these processes to automated, introducing ML ops to your process, really does not only improve your speed of delivery, but can improve the quality of your delivery as well.
ML ops, this is an interesting one, because I hear these terms used interchangeably a lot, ML ops, DevOps.
Yeah.
How do we differentiate between these?
I mean, it almost sounds like we made up another term, right? DevOps is great. I love DevOps. I love the idea that developers and operations work together to have a consistent deployment of an application into production. What we're seeing with ML ops is taking that same idea of DevOps and extending it out to the training and the data curation and all of those other things. So there's still that code, test, verify cycle that you do. It's just extending that into the model area and pairing it with your DevOps process so that you can get those models out to production. If you have the shorter cycle time you have, the more value you can demonstrate.
Okay, so thinking about automation, I think I mentioned coming from a manufacturing background. I think automation,
Sure.
I think process, hard boxes. But what you're talking about here in terms of automation is around training, the process of training the actual model.
Training is the start, right? Like, training is definitely part of it. Like, data scientists and are scientists. They're not engineers. They're not data engineers. I mean, they could be. But they're looking to solve the problem, right? They're not necessarily looking to surround that with a service, put that in a container, know the deployment environment, know if it's, like, especially when we talk about deploying things to the edge, know what that deployment environment looks like in terms of CPU, GPU resources, disk, the latency to those machines. Like, that's where this ML ops kind of comes in, is that we're tightening up those cycles and able to validate that work before it gets into production, right? And that's kind of the trick that I'm talking about today, is that it's not just about getting it done faster. It's like getting it done faster consistently so that you can demonstrate value.
Is that different than testing?
Yes, right? So, like, testing is still, I love testing, right? Like, I've been a software engineer for a very long time, and I still love unit testing. Unit testing is great. If I give you X, I should get Y. And we should still be doing that, and that we still see that that's how we validate our models when we train. We give inputs and we train to the expected outputs. We extend that to unit, like that unit testing to integration testing, right? So now, does my whole application behave as I expect it to? Those are good things, but like, what Mil5 has kind of figured out is that there's another level to this before you go to production, and we call it performance engineering. It's taking that integration testing, that unit testing, and combining that with more testing or more qualification to ensure that your application runs as expected in a deployed environment without testing in production, right? Like, that's the worst thing that you could do. You could do that. But it's to try to figure out how this works. And this way, like scientists, we can hold variables constant and change things and see their effect. And that is really what we need to be doing more of, is we need to be holding things constant and seeing the effect of the changes that we do.
Is that then similar to test loading?
No, right? So load testing is part of this, right? It's like load testing makes sense in some cases, but when I'm in financial services and I'm talking about trade data or like daily trade data, I may not be able to simulate that kind of load in my testing environment. It may be impractical. It may be cost prohibitive, right? But there are ways that, tricks and techniques that you can do by not very intuitively, but like slowing down the system and introducing latency or introducing constraints where you can start to see the effect that then scales into production. So you can simulate a production-like environment without spending money on production-like resources. And putting that as part of your pipeline, putting performance engineering as part of your pipeline really does kind of help qualify your push to production.
Okay, so talk to me about that. Where in that pipeline does performance engineering sit?
So it's after that integration testing, after unit testing, after integration testing, it's that last step before production. It's, we see subtle changes impact performance all the time, and things that we wouldn't necessarily expect. We often are throwing our trained models inside of containers. And I love containerization. It's a great way of isolating the machine from the environment. But things like changes to the kernel version, changes to drivers, changes to the inputs to your model could easily impact that performance. And unless you can measure those effects, you can't be sure about what is actually going into production. So that's where that performance engineering kind of comes in. It's extending those integration tests so that they now can model your deployment environment and that you can have higher confidence that, like, when this goes out into production and Cyber Monday hits, that my application handles the load. That if I'm in a failover scenario, that my application doesn't fall over and half my customers lose their connection, right? Or if I'm in an IoT environment and I have high latency, right? That I'm not losing messages, that I'm still able to process these things. Being able to simulate that and model that in performance engineering before you go to production is kind of key.
Okay, so we've talked about a lot here.
Sure.
Right? We're going to pick a process, we're going to automate it, we're going to introduce the MLOps, we're going to then use performance engineering at the end of this.
Yep.
Where do I get started?
So if you start just by automating your process, you're better than most. There's still too much by hand work that goes on. If you extend that MLOps, if you can test and train consistently, if you can reduce your cycle time, so instead of training a model in 24 hours, you can cut it down to 12 hours. Well, you can return value faster, right? You can prove that your assumptions are getting better. And if you can put that performance engineering as part of that automation pipeline, then you have higher confidence when you go to market. And that's really that kind of key, is that you want to make sure that the changes that you're making are impactful, but impactful in a positive way, not necessarily a negative way. You want to make sure that any change that you make that you think improves your product doesn't negatively impact performance.
So, a buzzword we hear about here, right? Data-driven organizations.
Yeah.
Another buzzword we hear a lot about, customer delight, customer centricity, all revolves around people, but we haven't talked about people yet.
It's true, right? I mean, we talk about MLOps a lot, and I've heard people say, oh, my data scientists can do that, right? Like, or my DevOps guys can do that. And those are not necessarily the people that you want doing that job. I think you can take a DevOps guy and train him to be an MLOps guy. I would be hesitant to take your data scientists and make them MLOps guys, right? I think this is a different discipline. I think that the things that those people are paying attention to, the things that those engineers or scientists or even data engineers are doing, those are specific jobs. They are not, I'm not creating a new job in the market. I'm creating a specific discipline, right? Because what we do, a data scientist should be focused on solving the problem. The MLOps guy should be focused on getting that trained model to production. Your data ops guy should be concerned with curation and data maintenance and data cleaning and stuff like that. Those are separate roles in your organization.
But all needed roles. Is
yes.
That,
yeah.
we hear about, we need more data scientists. Sounds like we need more data jobs.
We need more data jobs, but we need more broad data jobs. I think that making your data scientists do it is a waste of their time. Or it may not, I don't know if it's necessarily a waste, but it's not where their skill set lies, right?
Do you see any collaboration issues then come into play? I mean, we've talked before, talking about data, your operations folks versus your IT folks, right? You see that is now introducing this MLOps person. What kind of internal issues are they facing? Do they face anything with your other?
I mean,
functions?
They are that champion to operations, right? It's like if you think about all the resources that go into training models or deploying them, if the expectation isn't, that these things have value, if it just is like if your data scientist says, oh, I need a 16-core box with 48 gigs of memory, like in AWS, in Azure, in GCP, those things are expensive, right? Like I don't want to give those to people who ask them for me. What I want to know is that actually what you need? And that's where that ML ops and performance engineering comes in. It's like the data scientist's job is to create the model that solves the problem. The ML ops guy and the performance engineering is to optimize that for the best cost, the best value performance, right? Azure, AWS, GCP, they would love for you to over-provision, right? They would love for you to pick peak performance and deploy to that. I hate to see people spend more money than they have to in these cloud services. I think that it doesn't benefit them, right? Like what would you do if you had $10,000 more a month that you're not giving to AWS, right? What different tool sets would you buy? What staff would you add, right?
If there's any questions from the audience, please jump up. There's a mic there as well. We'll take any questions as well. But in the meantime, I did have another question for you on that cost part. I think as we've seen the industry over the last few years, you see speed changing, you see accessibility changing. How are the cost models then changing here from some of this technology development you're talking about?
That is a great question. I always look at this. There's speed to market isn't necessarily quality to market, right? It's speed and quality have to be paired together. Being first isn't always the best, right? Pushing your models out as fast as possible isn't necessarily the best thing if you go from having an acceptable SLA to having an unacceptable SLA. Like if you have a chatbot and it goes from answering questions nearly imperceptibly and it feels like someone's actually having a conversation, to those chatbots having long pauses or not being able to answer it correctly because it's making more decisions. People think that those things are broken, right? Like if you're on a web page and it's not responding, people hit F5, right? They think something's broken, right? The same has to be true for these models, right? So that's why we test, right? That's why that speed to market makes a difference, but the quality to market is is as important as well. And I think that that's where a lot of people are kind of missing. That's where we see a lot of people struggling, is that their initial idea works, but the minute they become a victim of their success and it scales up from 10 people to 100 people or to 1,000 people and it starts to fall over, that's a problem. And then it seems like it doesn't work. If you can model for that, if you can test for that prior to going out to market, that has value. That has way more value than the cost that it takes you to do that validation.
And there's, going back to this idea that you're in highly regulated industries, let's talk about responsible AI. When in the model, when in the training process, do you address this, and how do you make sure you test for it before going out to industry?
I mean, that's why we have that extra kind of step. If you're just doing unit testing, if you're just doing integration testing, you're not looking at responsible AI, ethical AI. You're not testing for bias in your models, right? If you know that that's key to your industry, if you have those specific things, now you have a place in that pipeline that you're never going to get something out there that doesn't pass that filter. And that, I think, it's a good point. It's not just about performance, but it's about, are we doing the right thing? Like, are we deploying to production something that doesn't have an inherent bias or an implied bias or an unintended bias, right? Because it all we introduce a new training set to our data, and all of a sudden it goes wrong, right? We should be testing that, right? And just because it passes our validation doesn't necessarily mean it's doing the right thing.
And have you seen that shift? Is now passing validation requiring that it is doing the right thing?
I would like to say that more people are doing it. I think that more people are aware of it. I think the big problem is that people don't know how to do it, or they do it by hand. They do it ad hoc, right? They do it quarterly, right? And I would say that that's too long, right? Like that, if it's not part of your process, if you don't have an automated process, if you don't have a place where you can plug this in and have that confidence, that high confidence, then you're only opening up yourself for problems.
So when we look at the whole process here, you start at the beginning, follow all of these steps. Do you functionally need to get through every single step? Or is there an MVP? Is there something you would say, start here? What's your advice?
Sure. I mean, it makes sense to, when we think about MVP, right? When we think about that, I think MVP is different than bringing it to market, right? Like, what we want to do is we want to iterate quickly and prove that we have value. At Mill5, I don't ever want to go 6 months without delivering something. I want to deliver value in a month. I want to prove that my assumptions are correct. At 2 months, I want to prove that this looks like this is going to work in production. At 4 months, I want to have alpha, right? At 6 months, I want to go to market with a beta. And I can, if I start with the idea that I'm going to be doing this automated process, I'm much more successful at being able to prove I have a good cadence. I know how long, if someone changes something on me, I can tell them the impact that has on my development cycle. And that's important. That goes back to Google's statement about the high-cost credit card, right? If you can prove that you have value, I think this is where a lot of people fail, is that they're spending money on training models, they're spending money on curated data sets and doing all this other stuff, and they're not seeing value being delivered. If you can deliver value along the way, if you can show incremental progress, then you're proving to the people who are paying the bills that you're doing the right thing. And that is kind of the key there. Because at the end of the day, someone is always going to pay the bills. You always have to prove that you're adding value. And I think that automation, having these specific roles of ML ops, data scientists, really does make sense.
Perfect. Well, thank you so much. This is very interesting. Thank you all. Oh, Sorry, we did have one question.
Yeah, I have a question for you. In regards to, I'm sorry. Yeah, in regards to the engineering, because you said a software engineer. I am a beginner software engineer. I'm trying to develop a cybersecurity company. And I realized the framework I'm using, Java and Python, they have several different advantages and disadvantages. How do you expect to put your application to help me expedite the testing part of the code to avoid weaknesses? Thank you.
Wow, I love the question, but it's a broad question, right? Like, I think that we are not limited by the languages that we use, right? I think what we are is you can write in one language and test in another, right? Like I think we should be, if you're, we don't necessarily know the decisions that go into the ML models that we create, right? Like, we're not necessarily always creating transparent models. Doesn't mean that we can't test them, right? So you should be picking languages or tool sets or whatever that allow you to quickly iterate on that stuff, right? So if you're writing in Java, maybe Kotlin is the best language for you to be doing integration testing in. If you're writing in Rust, maybe you're testing only at the application level and you're doing, different types of you're testing at maybe your REST edges or your gRPC edges. And then you could be writing it in any language that you want. You could be writing them in JavaScript but as long as you can track, like you're doing the right things and you're keeping the metrics and you're looking at, and you're testing the right things, I think the languages that you choose is not important as much as your goals, right? Does that answer your question? I hope I am.
Yeah, you kind of touched it, but what I would like to know is sorry. what I would like to know specifically is there a way to actually expedite the testing form in regards to determine is a mainframe or a structure is viable enough to prevent hacking?
I don't have enough time to answer your question. Please come and see me. I'd love to have this conversation. You and I would have fun, right, talking about this. But this is more time than I have on stage today. I'm sorry.
Thank you so much, though. This has been great. Thank you all.
Thank you.